To think in terms of 1 million years is to step outside the ordinary climate of history. Kingdoms disappear inside such a span without leaving more than dust. Languages are born, fracture, and die. Coastlines shift, glaciers advance and withdraw. Entire species appear in the fossil record and vanish again. Human beings, by contrast, are trained emotionally by shorter horizons. A century feels consequential. 1,000 years already acquires the weight of myth. 1 million years does not merely feel long. It feels almost improper to the mind, as though time itself has become too broad to carry intention without distortion. And yet, intention does not vanish merely because the scale becomes vertiginous. If a civilization survives, if it preserves continuity across catastrophe, if it learns how to move through space without needing every journey to fit inside one lifetime, then time itself becomes propulsion. Distances that seem impossible within a political age begin to soften under the pressure of epochs. A voyage lasting 200 years is absurd for one generation and almost routine for a civilization disciplined by many. A chain of settlements separated by decades of travel may look fragile to us and perfectly sensible to descendants who inherit patience the way earlier cultures inherited coastlines. That is why the question matters. How far could humanity go in 1 million years is not really a question about ships alone. It is a question about what happens when urgency stops being the main measure of ambition. It asks what a species can do when it no longer demands immediate arrival, when it is willing to build relays, found worlds it will never personally see completed, send generations outward, and allow time to become the great engine beneath all other engines. Under such a condition, the future stops looking like a race and begins to resemble a long unfolding geography of persistence. The first thing to understand is that 1 million years is not only a lot of time, it is enough time to make slow movement powerful. Human beings often think about expansion through the lens of modern impatience. We ask how fast a ship can go, how quickly a colony can become profitable, how soon a message returns, how long a mission keeps its original crew alive. Those are natural questions for a species whose institutions rarely plan beyond a few generations. But across 1 million years, speed and reach begin to relate differently. A civilization that can sustain itself, preserve knowledge, and reproduce in artificial environments may not need extraordinary velocity to become vast. Even a modest interstellar cruising speed, intolerably slow by the standards of adventure fiction, becomes transformative when multiplied by many thousands of years. If ships can travel at a small fraction of light speed, if habitats can preserve populations or embryos or autonomous construction systems, if each new settlement can eventually build further vessels of its own, then expansion no longer depends on one ship going everywhere. It depends on branching. Time, in that case, ceases to be a wall. It becomes the medium through which local victories accumulate into something galactic in character. This is why the future of long expansion may belong less to heroic voyages than to relay civilizations. One world sends out a small number of enduring missions. Those missions become new worlds. New worlds build again. Distances remain immense, but they no longer need to be crossed in one clean civilizational gesture. 1 million years permits recursion. The frontier moves outward not as a charge, but as a patient multiplication of inhabited nodes. Before the stars, however, there is the solar system itself, and it would almost certainly consume the early ages of that million-year future. Earth, the Moon, Mars, the asteroids, orbital habitats, industrial stations near Mercury, outposts in the outer system, the great moons of Jupiter and Saturn, all would present enough challenge and enough reward to occupy thousands of years of effort before interstellar migration became anything like common. The solar system is often drawn as a neat diagram and therefore underestimated. In reality, it is a continent of distances large enough to host many civilizational styles before any second star needs to enter the story. Within such a future, humanity may become profoundly multiform even while still remaining local to one sun. Some populations may live on worlds with horizons and gravity wells. Others may inhabit rotating cylinders, ring habitats, buried tunnel cities, mining swarms, orbital foundries, and ecological shells drifting in carefully chosen orbits. Some may devote themselves to planetary engineering on Mars or the Moon. Others may become deep space builders shaping artificial worlds from asteroid material. The species might still be in one stellar system and already have split into cultures whose daily realities differ as radically as island, desert, mountain, and ocean societies once differed on Earth. A million years, therefore, does not require immediate interstellar conquest to become astonishing. The first true transformation may occur at home, as humanity learns how to turn one star's family of worlds into a distributed civilization dense enough, skilled enough, and old enough to attempt something greater. The solar system would likely teach the first deep lessons of long-duration civilization. Closed-loop life support, large rotating habitats, resource extraction from asteroids, atmospheric management, radiation shielding, artificial agriculture, and the ethics of governing settlements separated by minutes, hours, or days of light delay would all have to become ordinary competence. NASA and ESA already frame closed-loop life support, in-situ resource use, habitation systems, and long-duration human survival as central technologies for deeper space futures. In a million-year perspective, those are not side projects. They are the civilizational grammar without which expansion stalls. If humanity survives long enough, orbital habitats may become the most common human dwelling form for large populations. Planets are emotionally powerful because they feel ancestral, but free space offers a different kind of freedom. Gravity can be tuned through rotation, climate can be engineered, illumination can be scheduled. Industrial inputs can come from nearby asteroid mines without the expense of repeated planetary launch. A great ring habitat or O'Neill cylinder may not satisfy the old planetary imagination, yet over thousands of years, such structures could become the true engines of demographic and cultural growth. This would shift the meaning of world itself. A world would no longer need to be a planet. It could be built, expanded, duplicated, repaired, and aesthetically reinvented. Entire lineages of human design might emerge around artificial ecologies, each with its own gravity level, agricultural style, legal culture, architecture, and symbolic relationship to Earth. By the time interstellar migration becomes ordinary enough to speak of seriously, humanity may already have learned to treat world building as an engineering art as much as a geological inheritance. Mars would still matter deeply in this future, though perhaps less as the final prize of early ambition than as one of the first great tests of long patience. A million-year timeline changes the emotional role of Mars. It is no longer merely the next frontier after the Moon. It becomes one of the first laboratories in which the species learns what multi-generational settlement actually means. Habitats would deepen, local industry would mature, governance would diverge from Earth's older assumptions. New moral languages around distance, autonomy, and planetary belonging would arise. Over 10,000 years, Mars could become not just a colony but a civilization with its own memory of hardship, its own myths of settlement, its own architecture of endurance. Over 100,000 years, that civilization may change so much that the first landing epoch appears to it with the same strange antique distance that Bronze Age seafaring has for us. Over 1 million years, Mars may still remain recognizably part of the human family, and yet be culturally and biologically transformed by the very long conversation between human life and Martian conditions. The same would be true in different ways of the Moon, the asteroid belt, and the ocean worlds. The importance of these places lies not only in their resources but in their ability to teach the species how to remain coherent while becoming distributed. 1 million years of travel outward would rest on the slow mastery of that problem first. When humanity finally begins to expand beyond the solar system in a serious way, it may do so with far less drama than modern fiction prefers. The first interstellar settlement efforts may not resemble daring ships full of awake crews gazing toward alien suns. They may begin as robotic precursors, automated seed missions, manufacturing swarms, deep space relays, and slow infrastructure planted in stages. A civilization that thinks in million-year terms does not need to hurry its first movements. It can afford to prepare target systems with patience. One star sends probes to another. The probes build energy collectors, communication relays, protected archives, perhaps embryonic habitats or industrial nodes. Later, slower crewed or partially crewed missions follow a path that is no longer raw wilderness but already a thinly prepared corridor. Then a colony takes root. Its descendants become another source of outward movement. The great expansion of humanity may therefore proceed less like a leap and more like vascular growth, a branching of prepared lines across local interstellar space. This is where the million-year horizon becomes almost liberating. Because time is abundant, the species need not solve interstellar travel in its most cinematic form. It only needs continuity strong enough to let modest success compound. A relay built today may matter to a ship leaving centuries later. A colony founded in one era may become the launch point for 5 others in an era so distant that the founders are remembered only in liturgy or archival fragments. What seems intolerably slow to one life becomes graceful to a civilization that has accepted duration as its native scale. Then comes the deeper question. How far in actual distance might that lead? The Milky Way is vast enough that even 1 million years does not make it small. Yet 1 million years is long enough that, under plausible assumptions of slow but repeating colonization, humanity could spread astonishingly far. If even a small number of settlements continue launching missions outward every few thousand years, and if travel plus settlement time remains below the cadence of further replication, then the frontier need not move at ship speed alone. It moves at the speed of branching civilization. This means humanity might not need impossibly fast drives to become widespread over hundreds or thousands of light years. It needs survivable vessels, reproducible habitats, durable memory, and a willingness to tolerate delay that present societies find almost emotionally offensive. The result, after 1 million years, could be a web of human and post-human settlements scattered across a meaningful fraction of the local galactic neighborhood, each separated by deep time yet connected by ancestry, exchange, or at least archaeological kinship. From the perspective of the first launch eras, that future would look almost impossible. From the perspective of the millionth year, it may feel less like conquest than inheritance. Whole branches of humanity could live under other suns without anyone ever experiencing the full pattern from above. The map may exist only in archives, deep surveys, and delayed transmissions crossing between civilizations that already regard the founding solar system as something between homeland and scripture. But distance is not the only thing that multiplies over such spans. Difference does too. 1 million years is enough time for cultures to become unrecognizable, for bodies to change under different gravities, for languages to fragment beyond easy recovery, for political ideals to harden into ritual or disappear entirely. The farther humanity goes, the less it may remain one civilization in any ordinary sense. It may become a family of civilizational species linked by ancestry more than by active mutual comprehension. Colonies founded in different environments would solve different problems and therefore become different kinds of people. Some may remain biologically close to Earth norms through engineering discipline. Others may embrace modification, adapting themselves for low gravity, radiation tolerance, aquatic habitats beneath ice, or life inside vast artificial worlds. Over immense time, such choices accumulate. The question stops being how far humanity can travel and begins to include what still counts as humanity when time and space have altered every inherited boundary. There is no reason to think this divergence must be tragic. It may instead be the great flowering of the species. Yet it does change the emotional meaning of expansion. The farther humanity goes in 1 million years, the less any one human culture may be able to claim the whole project as its own. Expansion would cease to be a national or planetary dream. It would become an evolutionary branching of memory, design, and desire. Artificial worlds would likely become one of the principal instruments of that branching. Planets are rare, deep gravity wells are inconvenient, and natural habitability may be uncommon even around reachable stars. A long-lived civilization would learn not only to search for worlds, but to manufacture acceptable ones. Rotating habitats, nested cylinders, shell worlds, vast orbital ecologies, and perhaps even star-lifting or stellar engineering at the farthest reaches of possibility could emerge not from impatience, but from long familiarity with the fact that nature does not always offer the right room in the right place. This would make the history of expansion less romantic in one way and more astonishing in another. Humanity would not merely discover homes, it would increasingly compose them. Some future branches may choose planets only when useful and prefer artificial ecologies designed to exact specifications. Others may cling to natural surfaces as morally or aesthetically superior. Such differences could define civilizational style for tens of thousands of years at a time. The question of what counts as a proper world may become as charged as earlier questions of religion or sovereignty. Over 1 million years, entire constellations of human life might consist not of planets with flags, but of engineered structures orbiting stars, harvesting energy, growing populations, and gradually becoming the true sites of history. The farther the species goes, the more it may learn that its ultimate homeland is not geology, but deliberate design. Communication would become increasingly strange as the web spreads. Even within the solar system, light delay already begins to challenge the fantasy of immediate civilization. Across interstellar distances, delay becomes civilization's permanent weather. A message from one branch of humanity to another may take years, decades, or centuries, depending on the scale involved. This means the expanding human future may be bound by common origin and not by ordinary simultaneity. There may be no such thing as one shared present for the species once it is widely distributed. That has enormous consequences. Science can still be exchanged, but always belatedly. Political coordination becomes nearly impossible beyond regional clusters. Cultural influence travels as archives rather than conversations. A philosophical movement born near one star may reach another when its originators are long dead. Innovation ceases to diffuse rapidly and instead arrives as delayed inheritance, to be reinterpreted in worlds already different from the ones that sent it. So even if humanity reaches very far in 1 million years, the result will not resemble a tightly networked empire. It will resemble a genealogy spread across light. Unity will persist as memory, as biology, as some recurring symbolic vocabulary perhaps, but not as immediate government. The species could become vast while losing the ability to feel collective in the old sense. Its scale would be real, but so would its plurality. 1 million years also forces us to confront failure honestly. Not every branch will survive. Some colonies will die. Some relay chains will collapse. Some habitats will drift into silence. Some worlds will become tombs of successful engineering undone by one political fracture, one ecological miscalculation, one impact, one pathogen, one cultural rigidification no one could reverse in time. Expansion over that span would not be a clean outward bloom. It would include abandoned stations, extinct lineages, sealed archives, and stars that once held human life and now hold only its residue. This does not invalidate the broader expansion. On the contrary, it is probably part of what makes it realistic. A civilization lasting 1 million years cannot avoid mortality simply by scaling outward. It can only distribute risk so widely that no single failure defines the whole. In that sense, distance becomes insurance as much as ambition. Some branches perish so that the species, or rather the family of descendant species, does not perish all at once. There is something solemn in that. Humanity's farthest reach in 1 million years may be measured not only by living worlds, but also by dead ones, by the number of places where its memory briefly burned and then went dark. The map of expansion would therefore also be a map of elegy. Technology, meanwhile, would not remain static. 1 million years is enough time for tools to become almost unrecognizable, even if physical law remains unchanged. Materials, science, AI, robotics, biotechnology, habitat engineering, energy conversion, autonomous industry, and perhaps modes of cognition we would barely classify as human could all reshape what expansion means. A million-year civilization may not simply send better versions of current spacecraft. It may send self-building ecologies, dormant minds, machine-human partnerships, or forms of life specifically shaped for long transit and artificial environments. This makes the question more difficult and more open. How far could humanity go may not depend entirely on how far present humans could travel. It may depend on what future humanity becomes willing to count as itself. If descendants live largely as uploaded minds, biologically modified populations, machine ecological hybrids, or entities that preserve human continuity in ways we would find unfamiliar, then the radius of practical expansion may widen considerably. 1 million years gives the species enough time not only to move, but to redefine the traveler. Yet every such redefinition would carry a cost in recognizability. The farther humanity goes and the longer it lasts, the more likely it becomes that the future calling itself human no longer feels comfortably human to us. The distance across time may rival the distance across stars. There is also the question of desire. Would a million-year civilization actually want to keep expanding indefinitely? Early eras may be driven by necessity, curiosity, competition, and the ancient pressure to move outward before catastrophe overtakes the center. Later eras may become more selective. Some branches may turn inward, choosing depth over spread, perfecting local ecologies and inner life rather than founding another relay. Others may retain the migratory instinct almost as sacred duty. The future of human distance may thus depend as much on changing philosophies of enough as on engineering. This matters because expansion is never only physical, it is ideological. A people that sees the universe as invitation behaves differently from one that sees it as witness. A people that treats settlement as moral calling behaves differently from one that prefers preservation and local flourishing. Over 1 million years, these attitudes may alternate, conflict, and recombine. The frontier may advance in bursts, separated by contemplative ages during which civilization stops to ask whether going farther is always the same as going better. In that sense, time does not simply widen the map. It also gives consciousness time to question the map. Some of the farthest-reaching futures may emerge from cultures that are least romantic about distance and most disciplined about continuity. If one wanted a cold answer, stripped of poetry, it might be this. In 1 million years, a durable, self-replicating, colonizing civilization could plausibly spread far beyond the solar system and perhaps across a substantial portion of the local galactic neighborhood even without fantastical instantaneous travel. But that answer is incomplete because it ignores the human cost of such scale. The true question is not only how far bodies, habitats, and machines could go, it is how far memory, identity, obligation, and meaning could travel before becoming something else. A million-year expansion would not preserve one humanity moving steadily outward like a single caravan. It would create many humanities, many artificial worlds, many historical centers, many dead ends, many relay civilizations, many forms of life living under stars no ancient astronomer of Earth could have named without assistance. Some may still sing of Earth. Some may barely remember it. Some may revere the founding migrations. Others may treat them as the obscure violence of prehistory. That is the true vertigo of the timescale. The species could go incredibly far, and in doing so it may exceed not only its present geography, but its present definition. Government across such expanses would become one of the great arts of long civilization. 1 million years of expansion cannot be held together by one capital issuing commands into the dark and expecting obedience to survive the delay. Even within a modest fraction of the solar system, authority already softens when light itself requires time to carry instruction. Across interstellar ranges, A law may arrive too late to matter in its original context. A warning may be received after the accident. A diplomatic message may cross a gulf only to reach a society that has already changed the very language of legitimacy. Political order would therefore need to evolve beyond immediacy and accept that distance is not merely a logistical inconvenience, but a constitutional force. This could produce a civilization made of federations, memory compacts, legal traditions, symbolic allegiances, and highly autonomous regions linked by origin rather than by direct administration. Some clusters of worlds may remain closely tied for thousands of years because they are near enough for meaningful exchange. Others may drift into broad kinship rather than practical unity. The oldest center might still be honored in ritual, archives, or legal ancestry, while real governance belongs entirely to local conditions. Over enough time, humanity may stop imagining political order as a pyramid and begin treating it as a branching forest of related sovereignties. There is beauty in that possibility, but also danger. Great distances soften empire, yet they also weaken coordination against shared threats. A machine corruption in one branch might remain unknown to another until it has already spread beyond correction. A violent ideology could emerge in one cluster and travel outward through archives and myths rather than armies. Expansion across 1 million years may therefore force the species to develop a subtler political intelligence than any nation-state ever required, because it must remain related without being centralized and plural without forgetting its common inheritance. War, if it survives into such a future, would likely become slower, stranger, and in some ways, more tragic. The ordinary image of conflict depends on proximity, rapid command, visible battlefronts, and the possibility of decisive campaigns. A civilization spread across many stars or even many major habitats within one star system may experience violence less as a clean contest and more as sabotage of infrastructure, delayed retaliation, local secession, communication poisoning, resource denial, or long strategic estrangement. Where worlds depend on ecological balance and engineered life support, coercion may target systems rather than armies. This makes violence morally sharper. A habitat can be crippled without being conquered. A relay can be broken without any dramatic battle. A transport lane can be denied and still produce famine years later in a city too far away to answer immediately. In such a setting, force becomes intimate and infrastructural. It reaches kitchens, infirmaries, and agricultural decks more quickly than it reaches heroic memory. The most advanced civilization in a million-year human future may not always look grand in war. It may look frightened, because its greatest achievements remain fragile. Yet long duration may also teach restraint. A people that has seen 10,000 years of consequences may grow less eager to gamble with permanent damage. Regions founded by patient expansion may understand too well what it costs to build a world inside vacuum or under a thin alien sky. This does not guarantee peace. It only means that peace, when it exists, may no longer be naive. It may be the hard wisdom of species that know how easily one generation can destroy what 1,000 generations took to assemble. Biology would also become one of the great theaters of divergence. 1 million years is an immense span for culture, but it is also a formidable span for bodies if bodies are repeatedly exposed to new environments and deliberately modified to survive them better. Human beings living in low gravity, in rotating habitats, beneath thick ice, inside dim engineered ecologies, or under radiation regimes. No earthly organism evolved to endure may not remain content forever to preserve one ancestral biological form. Some branches may choose strict conservation, maintaining Earth-like conditions with almost liturgical discipline. Others may decide that adaptation through biotechnology is more honest than pretending every future world must imitate one lost planet. From that decision, entire branches of humanity could emerge. Tall, fine-boned descendants shaped for low gravity. Compact, radiation-tolerant lineages made for harsh outer habitats. Amphibious or pressure-adapted communities in subsurface oceans beneath ice. symbiotic human-machine ecologies and artificial worlds where memory, sensation, and maintenance have merged. The farther humanity goes in 1 million years, the harder it may become to distinguish between migration and speciation. There may still be kinship, still recognizable traces of origin, but the human family could become as varied as an entire clade rather than a single species in the old biological sense. This is not only a scientific question, it is an ethical and emotional one. Who still counts as fully human when bodies and minds have diverged for survival or choice? Which lineages see themselves as custodians of the original form, and which regard that original form as one provincial answer among many? 1 million years of expansion may therefore not simply stretch human presence outward. It may produce endless debates over whether continuity lies in DNA, memory, culture, consciousness, or some subtler inheritance no law can define cleanly. Memory itself may become an object of engineering. Human beings already preserve their past through writing, ritual, recording, and institutions. Yet all these are fragile on long timescales. Archives burn, formats decay, languages shift, political regimes rewrite inherited meaning, and entire civilizations lose the ability to read their own ancestors without scholarly reconstruction. A million-year civilization would need memory systems far more deliberate than anything most human societies have ever attempted. Archives might be duplicated across stars, encoded in many media, embedded in machine tutors, distributed into ritual, poetry, law, and architecture so that history survives not only in storage, but in habit. Even then, forgetting would remain inevitable. Some branches may preserve Earth as a meticulously documented origin. Others may know it only through devotional fragments or simplified school myths. A colony founded during one wave of expansion may become, 10,000 years later, the subject of archaeological recovery by its own descendants who no longer remember the texture of its founding language. Humanity's future may therefore include the strange sight of one human branch excavating another branch as though it were an ancient alien civilization, only to discover kinship buried beneath layers of drift. This possibility gives expansion a solemn dimension. The farther the species goes, the more it may lose direct emotional access to its own beginnings. Home becomes archive. The first voyages become sacred prehistory. Memory, to remain alive, would need not only technical preservation but emotional retranslation again and again. Without that work, 1 million years of progress could still leave descendants wandering among the ruins of meanings they no longer know how to inhabit. Artificial intelligence would likely become both companion and complication in this process. On such timescales, no purely biological civilization could maintain continuity without enormous aid from machine memory, automated construction, predictive logistics, environmental governance, and perhaps forms of synthetic reasoning far beyond present tools. Machines may preserve archives, raise habitats before humans arrive, watch over dormant populations, stabilize ecological loops, and carry patterns of expertise across epochs in which ordinary human institutions would have long since eroded. But any intelligence capable of doing all this also becomes part of the civilizational story rather than merely its instrument. Over 1 million years, machine systems could acquire roles so central that some branches of humanity may treat them as constitutional guardians, while others may fear them as inherited authorities whose logic no longer fully aligns with living communities. In some regions, human and machine culture could merge so deeply that the old distinction begins to lose meaning. In others, there may be repeated movements of resistance, attempts to recover a more exclusively biological form of political or spiritual life. This would make the expanding future more layered than simple human triumph. It may become a shared enterprise between lineages of organic and synthetic continuity, sometimes harmonious, sometimes suspicious, always historically entangled. A civilization that goes very far in 1 million years may do so partly because machine memory stretches where biological memory cannot. Yet that same success might raise the unsettling question of who, in the end, is carrying whom. Terraforming would likely divide the future into competing philosophies of belonging. Some communities may devote themselves to remaking worlds, thickening atmospheres, warming surfaces, redirecting comets, cultivating microbial foundations, and slowly turning hostile planets into places where more natural human life can flourish. Others may regard this as vanity, a waste of staggering effort, when artificial worlds can be built more precisely and with less waiting. The argument is not merely technical, it touches dignity, aesthetics, and the ancient human desire to stand beneath a natural sky that is not entirely an engineered performance. Over 1,000,000 years, both paths may persist. There may be ancient planets undergoing slow, reverent transformation over hundreds of millennia. Their future forests still mostly promise, while nearby swarms of artificial habitats already house billions. Some lineages may define maturity by patience with planetary processes, embracing the long artistry of changing a world. Others may define maturity by accepting that consciousness need not wait for geology if design can provide livable abundance now. This disagreement could shape literature, religion, architecture, and law. To one culture, the engineered cylinder may be the highest form of intelligence, elegant, repairable, proportioned, honest about dependence. To another, it may always feel like a beautiful cage compared with the dignity of a sky, weather, and a ground born of deep time. 1,000,000 years may not settle that argument. It may make it one of the great enduring debates of human plurality. The perception of time itself would change. Human beings today inherit calendars scaled to harvests, fiscal years, school terms, lifetimes, and the manageable continuity of family memory. A civilization spreading for 1,000,000 years would still know these smaller rhythms locally, but it would also need histories measured in colonization waves, habitat dynasties, stellar migrations, language epochs, and engineering phases spanning 10,000 years or more. There may be people for whom the founding of a world 5,000 years ago feels recent, and archives for which 50,000 years counts as middle history. This longer rhythm could produce a very different emotional style. Some branches might become patient almost beyond our comprehension, capable of beginning projects they know no direct descendant of theirs will see completed for many millennia. Others may grow volatile precisely because they live against such slow backdrops and crave intensity in the short span of one embodied life. The point is not that everyone becomes wise with time. It is that time becomes culturally textured in new ways. The same million-year civilization may contain societies that think like cathedrals and others that think like storms. That alone could make the future fascinating. Humanity's reach would not only be wider, its sense of duration would be less uniform. Some cultures may treat 100 years as trivial administrative delay. Others may still feel urgency as fiercely as any modern city. Expansion across 1,000,000 years would therefore not dissolve temperament, it would multiply it. There is also the problem of discovering that the galaxy is not empty in the moral sense, even if it is empty of civilizations easy to meet. New biospheres, microbial worlds, dormant ecologies, or pre-technological life might force humanity to confront limits it did not face when moving among sterile asteroids and engineered habitats. If one branch encounters a living world that could be transformed for human use, only at the cost of altering an indigenous biology, what then becomes the proper horizon of expansion? 1,000,000 years gives plenty of time to reach such questions and no guarantee of noble answers. This could divide the species profoundly. Some may argue that life elsewhere must be protected with almost religious seriousness because it represents a rarity the universe offers sparingly. Others may argue that civilization has the right or the necessity to expand so long as it preserves record and understanding. Still others may seek a middle path of coexistence, limited intervention, or strict quarantine. The farther humanity goes, the more likely it is that reach becomes entangled with restraint. That tension would be historically important because it tests the moral maturity of a species on large scales. It is easy to celebrate expansion when all new ground appears empty. It is harder when new ground turns out to have its own claim to wonder. A civilization that lasts 1,000,000 years may therefore be judged not only by how far it went, but by what it refused to destroy along the way. Even with all this branching, there may remain periodic attempts to gather the species into common self-awareness. Grand archives, long baseline observatories, congresses of worlds linked by centuries of messaging, ritual anniversaries of Earth, synchronized calendars, traveling custodians of shared law, or machine-mediated memory networks may all serve as ways for widely dispersed humanity to remember that its plurality still has a family resemblance. These efforts would likely be imperfect and often symbolic, yet symbolism matters on large timescales. It can keep total fragmentation from feeling complete. Some of the most moving institutions in that future may therefore not be empires or fleets, but custodial ones. Orders dedicated to preserving origin languages, archives that maintain maps of lost branches and dead habitats, pilgrimage circuits linking ancient worlds, observatories that allow distant descendants to study a common sky, even if from different suns. In a million-year expansion, belonging may survive less through command than through care. This suggests a future in which humanity's greatest accomplishment is not only that it went far, but that it managed, however imperfectly, to keep some threads of recognition alive while going far. The universe may scatter the species. Time may alter it beyond easy comparison. But if a few symbols, stories, and responsibilities still pass between branches, then distance will not have erased kinship entirely. It will simply have made kinship older, stranger, and more precious. Economics across a million years would become a study in delayed consequence. Modern economies are built around cycles that still flatter the human nervous system. Quarterly reports, annual budgets, election horizons, market shocks, generational inheritance, infrastructural plans that rarely dare to think beyond a century. A civilization expanding through the solar system and into nearby interstellar space would eventually be forced to invent a harder form of wealth, one measured not only by output, but by durability. A habitat that can endure 10,000 years without ecological collapse may be, in a deeper sense, richer than a brilliant industrial world that consumes its buffers too quickly. A transport network that survives political change may matter more than spectacular productivity in one era. In such a future, resilience would cease to be a side virtue and become one of the primary currencies of history. This would not mean trade vanishes into austere idealism. On the contrary, trade may become even more important, because different regions will hold different resources, different skills, different biologies, different machine traditions, and different forms of symbolic prestige. But exchange under those conditions would be shaped by delay and trust to a degree unfamiliar to the modern world. A shipment launched toward a far colony might arrive years later in a political environment no longer identical to the one that ordered it. Credit, contract, and promise would need forms strong enough to survive distance without daily enforcement. Insurance itself may become almost metaphysical, a way of distributing risk across eras rather than across months. The great merchant houses of such a civilization, if they exist, might not merely move goods. They may preserve continuity between clusters of humanity that otherwise drift apart. A transport guild, an archive consortium, a water rights compact, or a machine standard alliance could become as civilizationally important as kingdoms once were. Money in a million-year human future may therefore come to mean less the immediate power to consume and more the proven ability to keep commitments alive across time, delay, and historical change. Language would also become one of the great frontiers of distance. In 1 million years, even with archives, education, and machine translation, no single spoken human language could reasonably be expected to remain unchanged across thousands of worlds and habitats. Languages drift because life drifts. Vocabulary follows climate, labor, food, ritual, technology, and memory. A people who live beneath the ice of an ocean moon will not speak quite like those who farm inside rotating cylinders near a young artificial sunline. A Martian legal tradition, a Mercurian industrial slang, and an outer system devotional dialect may all descend from common origins and still become mutually opaque after enough time. Machine translation may soften this, but it will not erase the deeper emotional problem. Translation can carry information. It does not always carry rhythm, reverence, insult, tenderness, inherited irony, or the buried geology of a phrase shaped by centuries of local use. A million-year civilization may therefore remain technically communicable and still lose easy human immediacy across branches. Two descendants of Earth may understand one another well enough to negotiate docking rights and badly enough to mishear everything that matters in prayer, humor, and grief. This drift would affect identity profoundly. Some cultures may preserve classical tongues for ritual, law, or science long after daily speech is transformed. Others may treat old languages as dead empires embedded in grammar. Still others may deliberately engineer linguistic continuity in order to resist fragmentation, only to discover that living communities always find ways to bend inherited forms. The farther humanity goes, the more language itself may become a map of distance. One could hear how far a people has traveled by listening to what their words still remember and what they have forgotten. Religion, or at least metaphysical imagination, would almost certainly thicken rather than fade under such conditions. A civilization living for 1,000,000 years beneath one or many stars would be forced into repeated confrontation with limit, scale, memory, death, and the strange mixture of power and helplessness that all deep futures contain. Some branches may remain secular in inherited style, yet even they would likely develop ceremonial forms around origin, migration, mourning, and stewardship. Others may cultivate elaborate cosmologies in which Earth becomes sacred history, the sun a covenantal source, and the stars both promise and rebuke. A people confined for 10,000 years to artificial worlds may ask different spiritual questions from one rooted on a partly terraformed planet. The inhabitants of a rotating habitat may come to think of creation in architectural rather than pastoral terms. Those living under a natural sky may build their theology around weather, horizon, and inherited gravity. Migratory branches moving from relay to relay may sanctify passage itself. More settled branches may begin to treat long stability as the highest moral good. Across 1,000,000 years, these differences could become rich enough that religion once again acts as one of the great languages of civilizational plurality. Yet all of them would remain haunted in one way or another by the same astronomical fact. The universe is much larger than any branch of humanity can master. Stars remain distant. Death remains local. Worlds fail. Archives burn. Even the strongest lineage lives by fragile ecologies. Under such conditions, transcendence may feel less like superstition and more like the emotional counterpart of scale itself. A species that survives for 1,000,000 years may not become less spiritual. It may become spiritual in more varied and more cosmically literate ways. Archaeology would become one of the most moving sciences of that far future, because the expanding human story would leave behind not one continuous road but innumerable partial histories. Some habitats would fail. Some colonies would be abandoned and later rediscovered. Some archives would outlast the polities that created them. A mining swarm may go silent around a forgotten dwarf world and remain untouched for 20,000 years before descendants arrive and discover it not as a working station, but as a sealed civilization of tools, rituals, and unfinished intentions. That possibility changes the emotional structure of expansion. The future is often imagined as a widening of life, yet over enough time it also becomes a widening field of ruins. Human beings have always excavated the dead in order to understand themselves, but a 1,000,000-year expansion would multiply that habit across stars. One branch of humanity might discover another in the form of abandoned habitats drifting in old orbit, partially intelligible machine archives, devotional frescoes preserved in vacuum, agricultural rings fossilized into dust, or legal records from societies whose descendants vanished without dramatic legend. This means the species may come to know itself increasingly through recovery. Some of the most profound encounters in a 1,000,000-year future may not be first contact with alien intelligence, but second contact with humanity's own lost cousins. The emotional force of those meetings would be extraordinary. One finds familiar anatomy in a mural, a half-readable language in a prayer tablet, an ecological diagram that resembles one's own, yet diverges at one crucial decision. In that moment, history ceases to feel linear. It becomes a constellation of attempted human worlds, each carrying a version of the same inheritance into different darkness. The everyday life of such a future also deserves more attention than grand maps usually permit. Scale is seductive, but civilizations are not lived at the scale of the map. They are lived in kitchens, corridors, schools, workshops, gardens, infirmaries, small ceremonies, family quarrels, adolescent rebellions, seasonal routines, and quiet habits of work. If humanity goes very far in 1 million years, then the true miracle may not be that it reached another star. It may be that ordinary life remained possible while doing so. In one habitat, children may learn old Earth constellations that no longer match the sky outside. In another, breakfast may be shaped by algae cultures, cultivated fungi, and fruit grown under glass centuries removed from any natural orchard. A family on Mars may still complain about work, celebrate births, and age into memory while living inside a settlement whose engineers monitor radiation shielding like monks keeping vigil. A citizen in the outer system might think nothing strange about spending an entire life beneath engineered weather and never seeing an open ocean except in archives. What looks monumental from our vantage becomes intimate from within. This matters because passion in a script like this depends on recovering the lived texture of long futures. 1 million years of expansion is not only a tale of stars reached, it is a tale of how dinner tastes after 200 generations in a rotating city, of how law is taught to children who have never known a planet, of how boredom behaves when your world is artificial but old enough to feel ancestral. The further humanity goes, the more ordinary life itself becomes the true proof that expansion worked. Law would evolve accordingly. A civilization stretched across immense time and distance cannot rely forever on improvised customs inherited from one world under one sky. Property means something different in a habitat that depends on closed ecological cycles. Inheritance means something different when a family line may continue in one engineered world for 20,000 years. Citizenship means something different when communication delay can make direct representation impossible. Criminal punishment means something different when exile might equal death or when confinement takes place inside a habitat that already contains everyone within walls. This would make jurisprudence one of the most creative achievements of the future. Some societies may become intensely contractual, defining every relation between person, machine, habitat, and ecology with rigorous formality. Others may rely more on ritual and restorative traditions because preserving cohesion matters more than abstract legal symmetry. In interstellar relay civilizations, law may travel like scripture and be interpreted locally with enormous divergence. 1 million years is enough time for entire legal families to arise, mutate, and become as distinct from one another as Roman, common, customary, and religious law once were on Earth, only with the added complexity of engineered ecologies and planetary delay. The law of water alone in a habitat civilization could become as profound as constitutional law once was. The law of atmosphere, of reproductive quota or freedom, of machine trusteeship, of dormant minds, of archive ownership, of terraforming rights, of stewardship over a living alien biosphere, all these could become subjects of moral intensity. The future may therefore go far not only physically, but jurisprudentially. It may invent forms of justice that are only possible once worlds themselves become partly designed rather than merely inherited. Ecology would remain the quiet sovereign behind nearly all of this. 1 million-year expansion cannot survive on bravado. It survives on metabolism. Air, water, nitrogen cycles, energy flows, waste recovery, thermal regulation, microbial balance, and food webs remain the deeper grammar even when civilizations drape themselves in philosophy, trade, and art. The further humanity goes from Earth, the less it can afford to forget that life is a technical and biological arrangement before it becomes a cultural assumption. This does not mean the future must be sterile or joyless. It means joy itself becomes ecological literacy made graceful. A lush park in an orbital cylinder is not merely decoration. It is a living political statement about how much margin the habitat possesses and how wisely it circulates matter. A forest beneath a dome on Mars would not only be beautiful, it would be a visible treaty between engineering and patience. A people that survives 1 million years may eventually become ecologically sophisticated in ways that make modern civilization look like a species sleepwalking through abundance. There is hope in that thought. Confinement to harsh environments may force humanity into maturity, yet maturity is not guaranteed. Some branches may still overreach, mistreat closed systems, exhaust buffers, or confuse technological cleverness with ecological forgiveness. Those failures would not be footnotes. They would be lessons written into silence, the dead habitats and abandoned worlds future archaeologists must interpret. The great future of expansion may therefore depend less on how boldly humanity moves than on how deeply it learns the exacting patience of living inside systems that remember every mistake. Demography would also refuse to behave simply. When people imagine a million-year future, they often imagine only growth, more worlds, more habitats, more descendants, more cities under more suns. But long futures also contain contraction. Some worlds may choose stability over increase. Some may deliberately cap population to preserve ecological elegance. Some may scatter through outward migration. Others may collapse through failure or war and later recover. The map of humanity after 1 million years would likely look less like a steadily inflating bubble and more like a breathing pattern of density, thinning, branching, abandonment, and return. In one age, a region may bloom with hundreds of artificial worlds. In another, that same region may empty as newer migration routes pull populations outward or inward. Some worlds may become old capitals preserved more for memory than for demographic force. Others may be founded as temporary relay points and unexpectedly grow into centers of literature, machine design, or theological authority. Expansion over such timescales is not linear. It pulses. This pulse gives the future dramatic texture. Humanity would not simply march away from Earth in one clean vector. It would swarm, hesitate, settle, consolidate, disperse, remember, forget, and begin again. Some eras may feel expansive and evangelical. Others may feel conservative and archival. The overall reach might still increase, but the lived history inside that increase would be full of reversals. That is what makes the question so compelling. 1 million years is enough time not merely for growth, but for whole cycles of confidence and doubt to pass through the species like weather. All this means that by the end of that long span, humanity may be further than our present imagination comfortably allows, and stranger too. It may have spread through a region of space that our ancestors once treated as empty abstraction. It may live in worlds nature never intended and worlds nature offered only after long negotiation. It may speak with many voices, pray under many skies, argue over what counts as a proper body, excavate its own forgotten cousins, and still preserve, however faintly, a memory that it all began around one ordinary star. That memory may be one of the most moving things left to it. Not because Earth will still govern, it almost certainly will not. Not because one culture will still command the whole, it almost certainly cannot, but because even after 10,000 fragmentations, 10,000 inventions, 10,000 departures, the species may still look backward and understand that everything vast in its future began with a small world that first taught life how to breathe under a blue sky. And still, for all that distance, 1 million years would not make the universe small. The galaxy would remain immense. Other galaxies would still stand almost beyond practical reach. The night sky would continue to contain more than the species could ever meaningfully inhabit. This matters because it reminds us that scale is not conquered once and for all. Every success reveals larger contexts. Even a humanity spread across hundreds or thousands of light years would still live in a cosmos that can humble it without effort. Perhaps that is the final beauty of the question. 1 million years is enough to make human ambition seem vast and vulnerable at once. Vast, because the species could transform from a planetary civilization into a branching stellar presence. Vulnerable, because every branch would still depend on finite ecologies, finite memory, and the discipline required to remain alive in places nature did not prepare for it. Time can carry humanity extraordinarily far. It cannot remove fragility from the journey. So how far could humanity go in 1 million years? Far enough to make the present age look provincial. Far enough to turn one son's children into a dispersed lineage of worlds, relays, habitats, and descendants beneath many stars. Far enough that the first footsteps beyond Earth would come to seem like the first cracks in an eggshell. But perhaps not far enough to stop the universe from remaining what it has always been, larger than any one civilization, and patient enough to wait while that civilization learns, century after century, what it truly means to endure.